the first term, last term, and the sum of n terms of a geometric progression are 3, 96, and 189 respectively. You want to find the number of terms in it, or basically you want to find the value of n, the number of terms in it, right? So let's make a note of the given information first. So the first term is given to us, that is basically the value of a, which is given to us as 3. The last term is given to us, so let's use a variable L for that. The last term L, we've given that as 96, and they've told us that the sum of n terms is 189. So they have given us a value of the sum of n terms. So I can say sum of n terms, S of n, is equal to 189. Okay. Now they've asked us to find the number of terms in this geometric progression with these parameters. Number of terms, if you guys remember, is nothing but, so we actually have to find the value of n in this question, right? Now let's try to recall our formulas. So Sn is given, sum of n terms, and the last term is given to us, right? So if you think about the last term, the formula which relates the sum of n terms and the last term, so that was Sn. We don't know the value of r, so let's just assume it to be larger than 1. So I can say Sn is equal to L into r minus a upon r minus 1, right? Now Sn is given, L is given, a is given, r is unknown, but there is no n in this formula anyway, so I wouldn't have been able to find the value of n through that. What about the other formula for Sn, which is which is a into r raised to n minus 1 upon r minus 1. Okay, so in this formula as well, if you really think about it, we have Sn, we have a, r is an unknown and n is an unknown. So this single equation has two unknowns, which makes it really difficult to solve actually, right? There is another formula which we could use to find the value of n actually, and that is basically the formula for the general term, right? We know Tn is equal to a into r raised to n minus 1, right? That's the formula for the general term. Here we can consider the nth term, the last term, to be the nth term. So we know Tn effectively. We know that is 96, the last term. We have a, but again in this as well, r is also unknown and n is also an unknown, right? So now we have two options. Either we can use these two equations, right, from which we can we get two equations with r and n, and we can solve them to get the values of those two. Or a better option would actually be to use the first equation here and this general term formula, because in the first here I can find the value of r because that is the only one unknown. Substitute that here and we will get the value of n, and that is what we're going to do here. So let's start with the formula for Sn. So I know sum of n terms with the last term given is actually L into R. So let's write that down. So L into R, which is minus A divided by R minus 1. R minus 1. So let's use this formula, plug in all the values that we already know. We know Sn is 189. So 189 is equal to L, the last term we know is 96, into R, which is an unknown, so leave that as it is for now, minus A we know is 3, divided by R minus 1. So again, R is still the unknown, so R minus 1. Okay, let's rearrange this equation to get the value of R. Basically, let's take the denominator from this side, from the left right hand side to the right hand, from the right hand side to the left hand side, sorry. So that will give me 189 r minus, and we want to find the value of r, right? So 189 r minus 189. On this side I get 96 r minus 3. Okay, let's further rearrange the equation such that we have r on one side and the other constants on the other. So I'll take the plus 96 from the right hand side to the left, take the minus 189 from the left to the right. Right? So I have 189 r minus 96 r equal to 189 minus 3. So minus 189 becomes plus 189 here. Anyways, if I calculate this here, I get the value as so 189 minus 96, that is 93 R, equal to 186. Alright, so now all I need to do is take the value of 93, take 93 from the left hand side to the right hand side. So R is equal to 186 upon 93, and if you calculate that, that's nothing, therefore I get the value of R as 2, right? 93 2s are 186, so R is equal to 2. So now that I've found the value of R, to find the number of terms in this geometric progression, I will actually, instead of using the sum of n terms again, I will actually use the formula for the general term of the geometric progression, right? So I can say let L, the last term, be equal to the nth term, right? Let last term be the nth term, which is equal to, by the formula of the nth term, a into r raised to n minus 1, a into r raised to n minus 1. So let's start plugging in the values. The last term we know is 96, right? So we know the last term in the series is 96, which is equal to, the first term is given to us to be 3, if I remember correctly. Yeah, L is 96, A is 3. First term we know is 3, so plug that in. R we found to be 2, so let's plug that in as well, to the power n minus 1. N minus 1, right? If I solve this equation, I should get the value of n, and I'll be doing just that now. So 3 from the left hand side to the, from the right to the left, becomes division, so 96 upon 3 makes it 32. So I have 32 is equal to 2 to the power n minus 1, right? Right. So both the sides have to should have the same base for us to proceed further, and 32 I know is 2 raised to 5, which is equal to 2 raised to n minus 1. So now since LHS and RHS both have the same base, I can equate the powers and say therefore 5 is equal to n minus 1, and if I rearrange that, therefore I get the value of n as 6, and so that means there are find the number of terms in the geometric progression, and that's what we got, the value of n. So there are 6 terms in the geometric progression. That will be my final answer. So therefore there are 6 terms in the geometric progression. This is my final answer, which I will put in a final answer rectangle.